All right, good morning. Let's start the lecture. So welcome back to UBC Okanagan, okay, and welcome to the second year. Okay. My name is Yan Chao. I'm your instructor. I will, in the first lecture, I'm going to go over is the syllabus first, and once I finish the syllabus, some of the key points I wanted to point out for this course, and then I'll start the lecture. And then the rest of the time for the lecture is basically some reviews on vectors concept, okay, and just to set up the stage for our future contents. Okay. First of all, I looks very like your previous instructor, Dr. Go, but don't mix me with him. Okay, I know you have taken course with him because I was approached by students many times submitting first year assignments. So let me go over the syllabus first. This course is Applied Science 248 Engineering Analysis 3, and I've been teaching this course for many years. This is a little bit info by myself, very short bio. I graduated in 1993 in a Bachelor of Engineering in China, and I got my Master and PhD from UBC Vancouver. So the interesting is my bachelor degree is actually in electrical, and my Master and PhD is actually was in mechanical. So I have a mixed background in electrical mechanical. So nowadays they call it mechatronics. So my research was in robotics and controls and mechatronic system. The lecture for this course, okay, Tuesday, Thursday in this room, 8 o'clock to 9:30. It's not the best time of the day. Honestly, I'm not a morning person either. So I would encourage all of you to come to the lecture, but inevitably I expect the attendance will drop as the day goes. Okay, so whoever sticks to the morning routine, 8 o'clock, and keep coming to the class, I think I will appreciate that. Okay, so education is reciprocal process. If I see a lot of students in this classroom, I will be encouraged. If I only see a handful of students in this classroom, and I will be a little disappointed. Okay, so that's why I would like to see people come into this class, and I try to make the class interesting. There are 6 sections of tutorial in this class that are here. We have 3 TAs. So the tutorial will start next week. Okay. Pick one tutorial section for you that works for your schedule. And the other thing is the tutorial. I typically use the tutorial as a very important means to supplement the lecture, the regular lecture here. The TAs have been doing the tutorial for several years, so they are pretty familiar with the course content, so they should be very capable of delivering the tutorial material. The other thing is the tutorial is we'll have 3 quizzes to be held in the tutorial somewhere along, maybe I forgot which week now. So by that time I will send a notice such that there will be a quiz next week, and then you should go to the tutorial and finish the quiz, and TA will mark it. Okay, and quiz, as I was going to tell you, quiz accounts about 5% of your total mark. My office is upstairs, 4235. Okay, and this is my email. The office hour, I tentatively said Tuesday, Thursday, but I'll see my schedule. I'll also see your schedule, because it's impossible to have an office hour works for everyone. Okay? But the general practice for me is, you're welcome actually to drop by anytime you want. Okay? If I'm there, feel free to come by and ask questions. That's fine. If you want to make an appointment, even better. Okay? In the past, I noticed is a lot of students actually tends to ask questions only at the end of the term instead of regularly coming here, right? And I actually like you to come, because you know what? Those who come regularly, actually I get to know them very well, and you know when you know somebody very well, and things improves, right? Yeah. So I encourage you to come to visit my office. Okay, probably not just course related. If anything else, that's fine. Okay, so there's 3 names of the TA. The names will be included in the syllabus, and also the emails of the TA. Feel free to send email to the TA too if you have questions regarding the tutorial. Okay. TAs not only to do the tutorial, they will also do the marking of assignments and marking of the quiz. TA will also help with marking the midterm and the final exam, invigilation of the midterm and the final exam. The information are in the syllabus. Okay, so I will upload to the Canvas later. Textbook. Now, textbook, most of you have kept the copy from your Applied Science 172 and 173. How many of you have bought that full version of Thomas Calculus when you were in the first year? Okay, not many, huh? How many of you don't have a textbook? Okay, so if you don't have a textbook, your option is you can either go get a multivariable basically the second half of this Thomas Calculus. But textbook is not mandatory in my class, and I typically will give you fairly clear and complete lecture notes. So if you come to the lecture, read the lecture notes, and do the assignments, and there's also some additional exercise, they should be okay. Okay, so most students can survive the course very well enough. But textbook does have more questions, examples. So if you feel like you're a textbook person, if you wanted to, use a textbook as a very formal reference, so I would encourage you to buy this one here, Multivariable Calculus. Any version is fine. As a matter of fact, any multivariable calculus book are fine. Okay. So here's my reference that you can use for this course. My lecture notes, tutorial notes, and occasionally maybe there are a couple just additional supplemental type of lecture notes. Okay. I will also record the lecture videos, so you get to watch you can watch the videos on the YouTube channels. If any particular assignments are very challenging, in the past what I did is I just give you some hints for some questions of a certain assignments, and then you can watch that if you're really having trouble with a certain question. Okay, yeah. So that's the reference, the type of basic resources available for this course that I will give it to you. And Canvas is also a very useful tool. I'm trying actually to model through this new system, Canvas. There's a discussion system on the Canvas. There's also a new assignment marking system. So I'm still trying to see that whether we need to submit a hard copy or just submit assignments through the Canvas. Anyway, so here's the cost policy that I would like you to follow for this particular course right here. Okay? Because this room, I taught a lot of the rooms on this campus. This particular room, I feel like the interaction is not as good as some other large classrooms, especially people in the back who wanted to ask a question. And also sometimes I feel when people in the back talking, they don't feel they're interfering with people, but actually people in the front, especially like me standing out here, can see clearly what's going on in the back. So if you can keep quiet, that would be perfect. And turn off the cell phone is one of the courtesy, the least courtesy you could do. Okay. So no makeup for the midterm tests unless you have a legitimate excuse. For example, you really get sick or there's some family reasons. Okay, and I can bump the percentage of the midterm test to the final. Okay. Submission of the homework, there will be a deadline. Okay, so if you can try to submit this before the deadline is fine. Otherwise, you can get a 0 for that particular assignments. Okay. Okay. Homework. There are about maybe formally 8 set of homework to be marked, and then the 9th homework will become a self-study type of homework. So officially there's 9 set of homework, but graded ones are only 8 sets of homework. Okay. As I said, I'm still looking into the possibility of submitting the assignments through the Canvas system. So the TA can actually just basically mark what you submitted, like PDF file, and then grade it immediately, and the feedback will go into your the grade system automatically. So we'll see how that works, and let's see if that can be that'll save a lot of paper actually, because in the past the papers submitted, students pick them up, and then so what happens is the paper just lying on the third floor, this whole pile of paper at the end of the term, right? Yeah, it's not very good. So, but in terms of the formats, I encourage you to use engineering paper, but it's not mandatory. You can still use white paper or any other line paper. That's fine. Okay, but you need to show all the steps. You need to write it clearly. Okay? I know some of you handwritings are very hard to distinguish. Some of you write really small letters and trying to cram all the question in one page. That's what we do not want. Okay? The TA could very well give you a bad mark or 0 if you can't identify or can't see clearly what you're writing there. Okay? So make sure spread the questions out. If the answer is very short for one particular question, you can probably put 2 questions on one side, but don't put too many questions to cram too many on one page. Absolutely don't use double-sided, just one-sided paper to finish the question. Okay, so write only on the front side, and write it big. Okay. Yeah. So that's about assignments here. And the other thing about assignments is I cannot design assignments completely different every year, and so basically the questions will be recycled. Okay. It's about math, it's about practice, right? So inevitably, some of you probably have solutions from your buddies, from last year, which is fine. Okay, so my purpose assignment is not actually trying to exams, trying to test you, give you a hard time. The purpose assignment is for you to exercise, to practice, right, to get to understand the lecture material. But the important thing is you have to do it yourself. Okay? You can work with your buddy, we can work with your friends, but you got to basically at the end of the day you got to write it yourself, right? You're not just gonna copy from any other resources. So because guess what? If you don't do it yourself, and you will suffer in the exam. Okay? And the exam is the moment to show the true color. So I would encourage all of you to do it, okay, and to do it on yourself, okay, and not just copying here. So some of the tools, actually this is not going to be the Connect anymore, so this will be Canvas. Okay. So I will upload everything on Canvas this year. Every course is using Canvas now. So you will find the course material on Canvas. And there's also YouTube channels, as I said, that I will upload my lecture videos on it. Okay. You probably will find strange is 246 because this channel started when I was teaching 246 a long time ago. So, but then you can't change the channel name anymore, right? So you'll find some other videos, some other type of videos on this channel, not just 248. Okay. So for questions and answers, I think there is a discussion. There's a discussion board on the Canvas. I'll make it available. I'm not sure how it works yet, so you're encouraged basically to ask any questions. Okay. Hopefully, actually, people, not just me, answer the question. I think hopefully every other student can also access and can also answer the question. So that would be perfect. Okay. The last time I checked, the Canvas has the functionality you can actually enter mathematical equations using. There's a tool called the LaTeX. Basically, you can enter all the nice math formulas. So that's good. So basically, sometimes this is a math course communicating a question. It's inevitable you need a description of integral or derivative, right? So that'll come in handy. So check that out, and that's one way to ask the question, okay? Especially in the middle of the night and you don't have anybody to contact. Ask the question over there. Examination. So there will be one closed book midterm exam and another closed book final exam. The grading of the course is homework will count for 10%. Remember I said the homework is not about punishment, it's about the exercise. If you want to get a 10%, it's easy. You just have to do it, you just have to finish it. Okay, it takes a little bit of time, of course. Okay. Not everybody got 100%, and in the past, those who didn't, usually at the end of the term, things start to get crazy, and they just skip one or two assignments. That one or two assignments could mean very important to you when it comes to the total grades for some of you. So I would encourage you to get the full mark 10%. Okay. Quiz 5%, which is what I said. There's 3 of them, which will be held in the tutorial, and there will be 1 question for each quiz. There's one, probably 2 questions. It takes, I'll give you guys about 25 to 30 minutes for each quiz. Okay. The quiz is designed to be relatively more difficult than assignment type of question. This quiz is actually more just for to prepare you to get ready for the exam. Okay, so that's why in the tutorial section you have more time to finish 1 quiz question. And my rule for quizzes is actually also open book, open discussion. You can also talk to, look at the notes, talk to your friends to finish the quiz. Okay, so that's the quiz. Midterm is 30%. The midterm, because we have 2 sections of the 248. So my section is 1.5 hour lecture, and the other section is 1 hour lecture each time. So it's impossible to have the midterm within the classroom. Then what we decided to do is the other lecturer, the other instructor, Lucas, is we're going to have a out of time midterm exam, and the date is tentatively set to be October 11. Okay. I look at the schedule on that particular day, which is Thursday. Your last lecture ends at 6:30, which is your 252 lecture. So I'm gonna book a room, start exam from 7:30. Give us 1.5 hours for the midterm. So that basically means finish the exam at 9 o'clock in the evening. Okay. So that information will be published on the syllabus, including the rooms and the time and date. Okay, yeah. So I think I'm going to book 2 large classrooms on the campus, the FIPK building and the arts building. So what happens is this section actually have a little bit less students than the other section. So instead of we'll see, maybe the strategy is we're going to just mix up all the students for this 248, and then we'll look at divide the student into 2 groups, just probably based on the last name or student number, who knows, and then we'll put you in the 2 classroom. Okay, so not necessarily all of you just be with me for the midterm or then with the other instructor. Okay. So that's midterm. Okay. My midterm are typically early, typically covers the first 3 assignments for this course. Final will be a little bit bigger percentage, 55%, and final actually will be a more comprehensive, much more comprehensive. We will talk about the final later, but the bottom line is final is not going to be accumulative, but as we're going to learn, as you're going to see, everything that we learned from the beginning till the end will be tested, especially the second half of the course. Heavily make use of what we learned in the first half of the course. Okay? So that's the beauty of this course here. There's no waste of time. There's no waste of your learning points. You're pretty much using everything for later part of the lecture. Okay? As a matter of fact, the later part of the lecture, the highlight of the course is the last 2 weeks. The last 2 weeks. And unfortunately, I probably won't see all of you, probably only less than half of you here. And the last 2 weeks, I repeat, is the highlight of the story right here. Okay? Because it literally used everything, 100% of what we learned, and apply to the contents that we're going to teach in the last 2 weeks. Okay. The other catch is you need to pass 40% of final exam in order to pass the full the course, even though your probably your total grades more than 50%, but you find it's less than 40, then unfortunately I'm going to have to fail you, and you will get, let's say, 47, right? Even though your total grade is above 50. Okay, so make sure you pass the final exam. So what do we learn in this course set here? Okay, so I'm going to just a very quick course content set here, and we'll go through the details later. Okay. I'm going to review the vectors concept, okay, and their operations, so as we're going to do today. And we'll look at lines and planes, but in 3D space. So you have learned in the first year basically a line which has a slope interception. That's basically 2D space. So how do we describe a line in 3D? And what about the plane in 3D? And what about the surface in 3D? Right? Plane is a special case of a surface. So that's the part we're going to look at the ways, the mathematical approach to describe equations to describe lines and planes in 3D. We'll also look at vector functions. That's a new concept. It's not just a function. It's called a vector function. Right? You combine a vector and a function together. And we'll also look at the derivatives and the integrals. So integrating vector functions in 3D. And then we'll look at the function multivariables and the partial derivatives. So this is also new in first year, Linear Analysis 1 and 2. And you learned basically function of the single variables. Everything you learn, derivative, integrals, they are all about basically function of the single variables. So now we're extending that concept to function for multivariable. And associated with that is this, instead of called a derivative, it's called partial derivative. Okay, so that we're going to look at that later. Similarly, we're going to do integration of a multivariable function. Now, because it's a multivariable now instead of you in your first year, you see there's one single integrand symbol, right? So now we're going to have double integral, triple integral, right? Depends on the number of variables for that function. So that's the course set here. Later, once we finish, we'll also have a surface integral, so-called surface integral. There's another part of this course is this is actually a topic closely related to optimization. So this topic here is called how to find a minimum and maximum for a multivariable function. Very similar, you have a single variable, you can find a minimum and maximum of a single variable function, right? Basically, what's the peak point and what's the trough, right, for a single variable function. Similarly for multivariable, we have a similar concept. Okay. That actually leads to optimization concept. And see, once we learn this, these last two bullets is what I mean by basically the last 2 weeks of lecture here. Divergence, curl, gradient, divergence, and the Stokes theorem. Okay, without getting into too much details here. So now these things here is basically the compact, the gist of this course here. This course is basically trying to help you with two other courses. One is in the electromagnetic field, okay, and the other one in the mechanical civil is called the fluid mechanics, okay, or aerodynamics later. Okay, so the concepts listed over here are the essential, the fundamental concept that you will make use of in the other two courses. Okay. So that's what I mean by the highlights of the course at the end of the term. Okay. So what exactly is the curl divergence here? So that we're going to cover later. Okay, we're going to come into detail. So don't worry about that for now. So I guess to cover a little bit of why this course set here. Yeah. Calculus, there is a huge debate. Should we learn calculus, right? And a lot of students graduated from the program come back say, I never touch calculus anymore when I'm doing my practical industry work. Right? That's very common comments I've heard from our students. Okay? But I think that's a very false statement. You don't use calculus does not necessarily means calculus does not exist around your engineering work, right? It's everywhere basically. The software you're using, the product, the results you're producing, okay, are directly or indirectly related to the calculus. For example, if you're working in the fluid mechanics area, engineering optimization, engineering electromagnetic fields, or numerical analysis, calculus is inevitable is there, right? Yeah. Sometimes we use our calculus without realize we're actually using calculus basically. Okay. So this course actually give you a peek into the real applications of some of the areas here. And this is what the model I give everybody at here called the journey of a calculus. Okay. In very short, I use 3 symbols. The first one is a straight D, and the second one is called the partial D, and the third one is called the del. So that's the journey at here. And what you have finished is basically the first part from the first year. And you're going to learn from here to here in this course at here. Okay? And I'll teach you what exactly these things means at here. Yeah. This is basically partial derivative, and this is a called the del operator. Okay. And this is also an operator here, right? So all of these are mathematical operators basically. So this is your journey. You finish this course. You literally finished a very important part of the journey for calculus at here. Very rarely, if you're not going to graduate study, you probably will not touch any or learn any other more calculus content. So that's it if you finish this course, right? Yeah. And 1 year before the final exam, one of the students, I don't know who posted outside the classroom. So the journey camp, will you reach the summit? And then they put my names there. Actually, I think I reached the summit already, and the question is whether you can reach the summit or not, right? Yeah. So I think most of you will be able to be very successful. Yeah. Just a quick tape. I think this applies not just to my course, but also apply to every other courses. Okay. I'm a very traditional learner type of person, so I encourage you to kind of follow these old models here. Before, during, and after the class. Yeah. Some students actually prefer to ask me to post the lecture notes before the actual lecture, so I will try to do that. Okay. So that's where you can, if you've got time, if you wanted to get ahead of yourself, what's going to happen today, so then you can look at the lecture notes, okay, and look at the material. During the class, okay, and this is my suggestion to everybody. I will write on the tablet, okay, and basically everything presented will be handwriting. Occasionally some figures I have prepared beforehand, so I will just show you the figure. But a lot of figure actually I draw it myself. So I encourage all of you to write at the same time as I'm doing the lecture. So get a good lecture notes, notebook. Or a lot of you have a Surface now, so you can use your electronic basic device to record the lecture. Okay. So the reason is learning basically has different type of stimulations to your brain, right? You listen, you write, and you speak. So that's all-dimensional type of stimulation to your brain in order to reinforce that idea. So that's why I encourage you to write. Okay. Now, this may not work for everybody. Some of you may feel I just can't catch the pace of the writing, and then I forgot to actually do some thinking, right? So that which is fine. You don't have to write every word down that I'm writing here. It's about notes taking, right? And if you feel you actually hindered by that approach, you can also just listen. Okay, that's fine too, and you can watch the notes later, right? You can read the notes later. After class, okay, I encourage you to review the material, okay, from the notes or from the lecture notes, or from the video or from textbook. Okay. And always ask yourself a question of why. So I found every year there are a few students actually challenge me because they ask a lot of whys that I never thought about. And when they ask why, I can't actually answer, and I find when I go back, I find I can actually improve the understanding of some of the concept myself. So that's why I encourage all of you to ask why. Even if you feel like you understand it now, you can still ask, so why is this from here, right? Is it from this step to the next step, right? Yeah, that's a very important learning actually technique. So that's before, during, and why. Okay, then sorry, after. Okay, do your homework, of course. Yeah. So that's my tape study here. Okay, yeah. All right, so a few more in here. So second year, you're gonna get a lot of other courses, projects now, especially. Okay. Take care of your management skill and keep it as it is if it works well. Learn how to take a good lectures and tutorial notes. Okay. Don't procrastinate and don't do practice. Okay. So the other thing is about this course is it's a math course. I don't expect all of you to fully grasp the concept, okay, at the moment during the lecture, for example, right now, right away. Right? That's impossible. But I try my best to convey the difficult concept in a much simpler way, simply to trying to explain it. But what happens if you cannot understand from the beginning, right? So this is the highest basically level of learning, understanding first. But if you can't, then my model is let's memorize it first. The beauty about the math is it's a pattern, right? You present a theory and you do an example, follow that theory. Right? Even though sometimes we don't understand what exactly the theory is trying to tell us, if I do an example, then I actually know, okay, so that's how I apply the theory, right? That's what I call the memorizing part. Okay? It's just like a routine that you're doing while you're playing a game or while you're playing some other strategies type of games at your own time. So try to memorize it here. The beauty of the brain is once you memorize it, once you actually practice now, at a certain point, all of a sudden it'll click, and then it'll lead you to some other basically places that actually makes you fully understand what happens in the beginning, right? So that's the part. If I can't understand right now at the beginning, let's memorize it first. You know, the worst part is giving up, right? Yeah. So. As a matter of fact, I remember my undergraduate study at here, and to be honest, I'm not the brightest student here in my undergraduate, but I did a lot of practice. Yeah. Last year when I go back to my home, which is in China, and I was sorting through my old stuff, and I found more than two my university math notebook, and I look at it. And I said, oh my God, this is exactly what I've been teaching in 248. Exactly the same thing. But I have no idea I did those things in my university career, right? So this is the point in here. So you memorize it, and you can still get a really good grades. But it will help you understanding, right, at a certain stage. I would encourage you to talk to me if you're really falling behind. Okay? Some of the students in the past, I actually able to ask them to come to my office regularly to make up some of the questions, which helped them already. Okay? So don't panic, talk to me. Go to bed earliest if that's a possibility. So last but not least, here's the model I will give to the student. Okay? Ability is what you are capable of doing. Motivation determines what you do. Attitude determines how well you do it. So I appreciate the most is the attitude here. Okay? Not the intelligence that's the most important, but attitude is the most important part. Okay? So that's a brief introduction to the syllabus. Okay? You will see similar information in the syllabus, especially this table right here. I will update this in terms of the midterm. So this is basically the schedules of the course breaking down to weeks. Okay, it's not going to be exactly the same, but it's more or less going to be the schedule for this course. Okay. Yeah. Any other questions from you guys? All good? All right. I'm sure you'll have questions later. So, okay. So let's, as I said, I'm going to make use of the rest of the time to start the review of the vector concept. Okay? Pardon me? Oh, interesting. So when I'm talking, that slide didn't show up here? Oh, it did, right. It was a tinted screen. So let me do this. Okay, so let's start from beginning. Vectors. Okay, we have used the vectors heavily in the first year already. Okay? So the vectors, basically what you see is you have an initial point A and then a terminal point of B. Right. So that's what you see for vectors in here. And that's how you indicate a vector. And sometimes you probably will see a number, basically see, okay, so there's a 3 or 4, and that indicates basically the length or the magnitude of the vector. Okay? Yeah. Vectors are very common mathematical symbols that you see because, you know, in the real world, there are many quantities that has to be described by a vector. For example, if you have a force, okay, if you have a velocity, and if you have a wind speed, right? You know, it's describing the wind. So you need a vector here. So why do you need a vector for those quantities then, right? Because why? Because you need a quantity that describes the direction and what? Magnitude. Exactly, right? So you need a quantity to describe these two properties associated with that quantity. So this is actually bringing us to basically the definition of a vector now. Okay. In short, I will just write it down. Okay, the vector basically has two components, or the definition is direction and magnitude. Or sometimes we call it length. Okay? Yeah. So vector is defined. Basically, definition means what? Definition means this is defined by this. Everybody agrees that this is basically, you don't need to argue, this is basically the rule, right? It's described or defined by these two quantities here. So I can see, okay, so this guy equal to the length times the direction. Okay, so that's vector. Okay, that's vector. The length times the direction. Then I'll come to details instead of just using words. Okay, so now before I move on now, so now I'm going to ask you a question. Now you everybody knows what the vector concept already, or vector definition already now. Okay, so let me ask you a question now. And here's a 3D space. Okay. And I'm going to draw two vectors. Okay, so I'm going to draw the vector over here. Okay, that's one vector. Okay. And now what I'm going to do is I will move this same vector here. Okay, this vector, without changing its direction, without changing its magnitude, I will move it to a different location. Is that good? Yeah. So basically, I copy the vector and then move it to a different location now. So let's call this as a vector, let's say A, and I call this as a vector B. Okay. And I will actually touch upon the notations just shortly. Okay. Yeah. So here's my question. Are they the same vector or different vector? Okay, so here's a simple question. A and B, are they the same vector or are they the different vectors? So I want to see the hands here. How many of you think they are the same vector? How many think they're different vectors? Okay, so there are a couple saying different, right? Yeah. They are, the answer is they are the same vector. Okay, so they are the same vector. So how did you make a decision why they are the same vector? Anybody? Why would you say they are the same vector? No, they're a different location. Yes?
They both have the same direction and magnitude.
Sorry, that's really.
Oh,
yeah, that's okay. Yeah. Exactly, right? They have the same direction and they have the same magnitude. That's the definition of the vector, right? That's definition, okay? Yeah. And that actually brings to a conclusion. So vectors are free, okay? You can move the vectors around, okay, as much as possible. But as long as you don't change the direction, you don't change its magnitude, you're not changing the quantity of the vector at here. Okay? Yeah. You're not changing the nature of the vector, basically. Good. That's a very simple concept, but actually it's a very important understanding of the understanding of a vector here. So I think I'm gonna talk about a little bit of notations for this course set here. Okay? Little notations. So as you probably see, when I write a vector at here, right, and I write with a half arrow on top of the symbol. So this half arrow at here, okay, basically indicates that this is a vector symbol. In some of the textbook, they use bold letter, right, to indicate this is a vector. But I cannot write a bold letter on the screen at here, so this is how I'm going to write this letter. So if I write A, B, same thing, that basically refers to vector here. Okay? Yeah. And the other thing is, when we write a vector, for example, if I have a vector A at here, any vector has to have components, right? If you have a 2D vector, then you're going to have 2 components. You have 3D vector, then you have 3 components. So for general vector, okay, if you have n components, this is how I'm going to indicate this vector at here. So A1, A2, AN, and they are enclosed by the so-called half brackets at here. So this is my symbol. Sometimes some other textbook will use a different, basically, maybe they use this, right? So which is fine. So this is how we indicate a vector at here. This is actually called n-tuple vector, okay, in n-dimensional space. Sometimes, in order to save time, I may not write a comma, but just if you're wondering, there are basically n number of components, right, inside the vector. That's fine. Okay, so typically in this class will be in 3D. In 3D space, so you have a 3D vector, okay, so A1, A2, A3, so that's a 3D dimension vector, right? Now when we draw this vector out in a 3D coordinates. So how you will draw the vector is, this is actually I find it sometimes confusing to some students here, is first if you have A1, A2, A3, right? So first find the coordinates, for this particular point described by A1, A2, A3. Now this actually brings to the second notation. Now the vector now it's called coordinates. So let's say I want to describe a point A using a coordinates. Now this coordinates is A1, A2, A3. So you see the symbol here now. Instead of half bracket, it's what? It's a normal bracket now, right? Yeah. This is not a vector now. So when we use a normal bracket, this basically means this is a coordinate. A coordinate essentially means the x, y components, right, of that particular point. And I can indicate this coordinates A at here. That's the coordinate. So essentially I use half bracket for vector, and I use this normal bracket for small brackets, and we call this small bracket, call this as big bracket, I guess. We use this big bracket, small bracket for coordinates. And then when you connect the origin O, which is the coordinate system, with the point A, you're creating a vector. And this vector, if I use in my normal notation, because start at O, ends at A, so I could also call this as OA vector, right? Because call it OA vector here. And that OA vector is basically this A1, A2, A3. So this is how you would indicate a vector. Now, if you move this OA vector, right, to somewhere else, not starting this vector at the origin O, which is absolutely okay. You remember vectors are free, right? So you can move it around, you can move it to somewhere else. Now this is still your OA vector. And this vector is still A1, A2, A3. Does that make sense? Same thing. Okay. As a matter of fact, you can use a simple basically properties, right, to derive the OA at here. Now OA vector, if you wanted to derive this vector, you could also see it's the coordinates of A minus the coordinates of C, right? That gives you this OA vector. So in other words, what you guess here is, what's the coordinate of A? Is A1 minus coordinate of not a C, the O, minus the coordinate of O, which is 0, right? X component 0, so A1 minus 0, and A2 minus 0, and A3 minus 0. So that's how you get this OA vector, A1, A2, A3, right? Okay, yeah. So if you have a arbitrarily 2 points, so let's say if I have a P and Q, and I wanted to know what's the PQ vector, given 2 points P and Q. Let's say, for example, maybe let me write on one more here. Let's say P point has x1, y1, and the z1 coordinates, and Q has x2, y2, and z2 coordinates. So if you have 2 arbitrary points, then your PQ vector is x2 minus x1, y2 minus y1, and z2 minus z1. Okay, and that's how basically this is a general formula now, right? This is general formula that we're talking about. Okay, so well, I'll go over some other notations as I'm going along here there. Okay, but so far, in terms of vector, this is essentially and the notation wise, this is what we need for now. Okay. Okay, so let's continue with some other concept here. So now we're talking about a vector now, and then let's look at what exactly is magnitude. Okay, so remember vectors to constitute two components, right? Vector and magnitude and direction. So let's look at what magnitude is. I can use this PQ vector to illustrate. If this is the PQ vector, then its magnitude, I use this for indication of the magnitude of the vector. So two vertical bars, okay, sandwiching that vector, meaning this is a magnitude or length. Some textbook actually use two vertical bars, okay, to sandwich this the vector. But I really just want to save some writing sometime, so I'll just use one vertical bar. Okay. So magnitude in this particular case is very simple. If this is the vector right here, all you need to do is you just need to take a square root and summing up the squares of each term or each component. Here, that's the magnitude. And if in terms of this vector OA here, and that's even simpler. That's magnitude. Okay. Good? Alright, so let's look at another concept called univector. Okay, univector. So univector is a simple concept. Basically means the vector's length or magnitude is 1. Okay, that's what the univector means. It doesn't matter direction. As long as you have a vector that its length is 1, then it's called a univector. So how do I derive a univector then, right? So let's say given a vector A already, any arbitrary vector, then I can derive my univector like this. So A hat, right? So this is what I denote a univector. A hat, okay, equal to this A vector, and then divided by its magnitude. Okay, so that'll give us a univector. And the way it does is basically you're normalizing this vector A so that its length become 1. Right? In other words, if you calculate this one, it will get 1. Right? You'll get 1 here. Now univector has a very unique actually application. So what we use univector is you use univector to indicate the direction of this vector. So that's basically a major application here. So A hat is the direction of vector A. Is that good? Yeah. That's univector. And now we have the application of univector to indicate the direction. And we just covered the magnitude. So, and now I'm going to be able to combine these two things together now, right? If I have a vector A, which basically has two components. One is magnitude, and the other is direction. So this vector A is the magnitude or length times direction. Right, so that basically ties the loose end of the definition of the vector here. Okay? Yeah. Now you probably will think this is simple here. We actually will make use of the simple concept, which is playing some higher level concept, okay, later. Okay, so that's basically the three important concepts here now. And the other ones, I think they're pretty self-explanatory. You should be able to grasp that very easily. I will probably just skip the details here. For example, what's vector addition and subtraction, right? Yeah. So that should be fairly straightforward. If you have two vectors, how would you do addition and subtractions? So that type of things. So I want you to look at the lecture notes and review yourself. Okay. Yeah. Any questions so far? It's all good? Good? Okay, let's continue now. Now the next one is an important concept to review. It's called the vector dot product. So we use a lot of dot product. We also use a lot of cross product, okay, first four. So let's look at the definition first. If I give you two vectors, A and B, if two vectors are given and you're required to calculate its so-called dot product, it's a product. A product basically means it's multiplication, right? You know, just like 2 plus 3 or 3 plus 4, that's a multiplication. But here it's not a single number you're applying, multiplying. Here's the two vectors you want to multiply. So that actually has a little bit different form now. And the first form of vector multiplication is called dot product, and the other one is called the cross product, right? So for this one here, you have two vectors and then separated by a big round dot and filled a solid dot. So the definition of this dot product is basically you can use a summation sign in here to write down the dot product. It's the summation of the multiplication of the corresponding components, okay, of the two vectors. That's dot product. That's dot product. A different name of dot product called the inner product or scalar product. Okay, it's the same thing, right? But one thing that you're going to be actually absolutely clear is the result of a dot product is what? Scalar. Okay, yeah. I still find some students having trouble actually at this stage here. So results of a dot product is a scalar here. Okay? It's not a vector anymore. It's a scalar. And a very simple property at here is if I use the vector to dot itself, okay, if I use the vector to dot itself, if you look at this, if I apply the definition in here, if I use the vector dot itself, what do I get? A1 square, A2 square, and then A3 square, right? Now, if I put a square root at here, guess what that gives us now? What does that give us? The length, exactly. Right. So that gives us the length now. Okay. So when you use a dot product to dot itself and then take the square root, you get back the length. And that's a very useful actually property. Okay, very useful. Okay, so here's the definition, right? Here's the definition. Now from the definition, there's another, you could call it, also call it definition. You could call it actually a different, it's an extension from the definition. So under the dot product, another application is, I call it basically geometric meaning. Okay. Or it's an application of the dot product. A dot B, okay. Instead of using this definition in here, we have a different formula. Okay. So this is the second part of the review for dot product, the geometric meaning out of here. So A dot B equal to the magnitude of A times magnitude B, and then times the cosine theta. So what it means, it basically means you have a, let's say, A vector over here and then B vector over here. They are separated by an angle of theta. Then when you use A dot B, instead of applying the definition, you could also calculate this dot product using this formula, magnitude A times magnitude B, and then times the cosine theta. The range of the theta can be 0 and pi. Okay, so no more than pi and no less than 0. It's not a negative angle. And this formula, actually, you can prove that. I will skip the proof. You can prove this using the so-called law of cosine. Okay. Basically, you can form a triangle at here. So this vector will be B minus A. So you can form a triangle, and then you can use the so-called law of cosine to prove this formula at here. Okay. So if you're interested, let me know, and I can show you how this formula is proved. So why is it called a geometric meaning? Because this formula here, actually gives us a really good sense of the relative location, okay, or configuration between the two vectors. A lot of the time, you probably say, okay, I got a vector here, and then I got a vector over here, okay. So, and that's a very common application in some or robotics or some other systems. So the first step you do is actually what? Move the two vectors, okay, and all the way together. Okay. So that's the first step you do. And then you will be curious, okay, so then what is the angle between the two vectors? Right, so that's one thing. And how do you get that information? That's very easy, because you have this formula now. So you can obtain the angle between the two vectors by taking the arc cosine, right, the inverse cosine. Okay. And then you can get the angle of this of the two vectors. Okay. There's a very special case that you probably will be interested. So what happens if theta is pi over 2? Means what? The two vectors must be perpendicular, right? Must be perpendicular. So if they're perpendicular, if you look at the dot product, if the perpendicular, what's cosine pi over 2? 0. So which means dot product equal to 0. So you could actually easily calculate dot product. You say, okay, so if you got a 0, which means the two vectors are perpendicular. Okay, that's a geometric relationship you can easily obtain by calculating the dot product between two vectors. So that gives us dot product equal to 0, or A perpendicular to B. Okay, A perpendicular to B. And we also sometimes call it orthogonal. A is orthogonal to B. That's very useful information. So, in high school, I don't know if you have done a lot of exercise geometry, like planar geometry, right? You prove is this line perpendicular to the other line sometimes, right? Now, before you learn vector concept, then you had to use a lot of basically relationship and then trying to prove this kind of perpendicular relationship, right? But when you after you learn the vector, you can actually use this quantity now. If I can calculate dot product somehow and shows 0, then I can prove that the two lines are actually perpendicular to each other, right? That's a simple application. Okay. All right. This is the dot product. Another thing about dot product, this is something that we will actually make use of also. I'm going to go through a little bit detail. It's called the vector projection. Okay, it's called a vector projection. So what I'm trying to do at this here is, I'll illustrate what I'm trying to do. Let's say I have a vector A at here, and then I have a vector B over here. Okay. So here's what I'm trying to obtain here. I will project this vector A onto the direction given by vector B. Project meaning it's a perpendicular. So if you're looking from the top, right, you're basically dropping the line all the way down to the other direction, and you have a basically perpendicular projection at here. Yeah, that's projection. So from here to here, and I'm gonna call this one here called projection of A in the direction of B and here. Okay, in the direction of B. So this is the symbol indicating this vector. So this vector over here, projection of A in the direction of B. And of course the idea is, what does it equal to, right? How do we derive this projection of A onto the direction of B? Now you see the description I just said here, right? So projection of A onto B, okay, onto the direction given by B vector. Okay. So let's focus on the second half here. Okay, projection onto the direction given by B. So the simple question I'm going to ask you now is, what is the direction of B vector? Remember? Pardon me? Unit vector. We just actually reviewed, if I want to use a mathematical symbol to indicate the direction of the B, what do I use? B what? B hat. Yeah. So my description is called B hat, right? So this is B hat here is an indication of that projection of A at here, direction of B at here. Okay. So basically this one here, I could also write it projection of A onto the direction of B like this. So A projection, this is B hat at here. Is that good? Yeah. So understand the meaning of the symbol right here now. So now let's derive this symbol here, right? Let's derive it. Now before we derive it, I just probably want to see, this is also, you probably also see this is in your statics. If you have a acceleration vector, right, and you will be interested to know, so what is the decomposition of this acceleration vector into this direction and the other direction, right? So that's how you can derive actually based on this derivation here. Okay. All right. So remember, I'm trying to derive this guy here, right? I'm trying to derive this. So let's say suppose the two vectors are separated by an angle theta at here. If I'm going to derive this vector, I'm going to start from the definition of the vector. What's the definition? Vector equal to magnitude times direction, right? Here's a vector, and I don't know the magnitude yet. We'll derive it. What direction is it? Given by b, which is what? The b hat. And so this is your direction here. And b hat literally equal to, according to our definition, it's b divided by its magnitude, right? So for the vector we're looking for, the direction in this bracket here, it's basically just b divided by its magnitude. That's the direction for the vector we're looking for. Okay, so that solves one part of the vector now. Okay, for the first bracket, remember the first bracket I said it's the length, right? That's the length set here. What is the length? The length basically is this absolute length set here, the distance set here. So I'm going to resort to my high school knowledge now. This is what? A right triangle here, right? It's a right triangle. And this is the hypotenuse set here. And I have a theta over here. So if I know the length of this hypotenuse here, then I can derive the length of this side. Does that make sense? Yeah. So the length of this hypotenuse is A absolute. And this is theta at here. So basically the length of the vector we're looking for is absolute value of A times cosine theta. Okay. So that's the length. So up to this stage, you basically have solved what this vector we're looking for here. But this is not the prettiest form probably, because you have a mixture of vector, magnitude, and then a theta, right? So I think we could do a little better to simplify this, at least. Okay. So here's what we're going to simplify now. I don't really like to see the cosine theta inside the brackets. I want to get rid of the cosine theta. How can I get rid of the cosine theta? So let's go back to our vector formula. I can get rid of the cosine theta by using this formula here, isn't it, right? So I can derive the cosine theta at here and then substitute back into this cosine theta. Is that good? So I'm going to replace the cosine theta with A dot B over A B. Okay. So I'm replacing the cosine theta using the geometric meaning, the geometrical formula for the dot product. Okay, everything else we'll keep it the same. Good. So now it's consistent. It's all about vector and the magnitude now, okay, within this formula. And the good thing is we can start to do some simplification. Let's say we can cancel any terms. So what can we cancel now? I guess I can cancel these two here, right? Okay, I got to be able to cancel these two. Okay, and then that's it. I can leave this inside as it is at here. So this become A dot B and divided by B, and then here is B over its magnitude, and I'm going to resort back to the B hat, okay, which is the unit vector. Is that good? Okay. So back to this first bracket. The first bracket, if you look at it, I can do a little bit more simplification here. I can separate, just look at this fraction, B over its magnitude. And what's B over its magnitude? We use the symbol what? B hat, right? So that gives us A dot B hat times B hat. Okay, so all the way here. So that's what we're looking for. The projection of A in the direction of B is equal to this. Okay, is equal to this. Now this actually tells us quite an important information in here. First of all, let's take a look at the first bracket. Okay, the first bracket here. You see in the first bracket is A dot B hat, right? A dot B hat. So let's get back to the beginning. What did the first bracket indicate? The first bracket indicated what? The length, right? It's the length of the vector. Which vector? It's this vector. So now you can see the results of the first bracket is what? A dot B hat. So now if next time if I give you a question, ask you, can you tell me what's PQ dot, let's say, U hat? So tell me what's the physical meaning of the PQ dot U hat? Yes?
The length of the vector on U hat.
Exactly. Right? Yeah. The projection, the length, in that direction, U hat. See, that's actually what dot product really, a lot of application is down to this symbol here. If you want to know the length of the projection, right? If you want to know the length of the projection, what do? You use the vector and then dot, not just another vector. You use the vector and then dot that direction. You get the length of the projection. Okay. So I'm going to stop it here, and we'll continue the review. But this is essentially an important application of dot product. Okay. Any questions? Okay. All right. I'll see you next week.